NASA's Perseverance rover, by far the most sophisticated vehicle sent from Earth to Mars, landed successfully on the red planet on Thursday night. Now, for the next 2 years, the car-sized vehicle will search for signs of life, launch a helicopter, and prepare the way for future humans to visit. Joining us now to explain the significance of the otherworldly mission is University of the Western Cape astrophysicist Professor Lerotodi Leo. A very good afternoon to you, and thank you so much for joining us.
Good afternoon.
Now, Professor, just talk to us about NASA's Perseverance rover's journey to Mars, focusing also on the landing and the importance of surviving the so-called 7 minutes of terror.
Yeah, so the journey took about 7 months, and quite a long journey where all the instruments, had to stay working and in good condition. During this journey, we heard a test of sound from one of the microphones on board. So we could actually hear a sound from space, using one of the microphones on this rover, that we'll also hear more from when the rover is on the ground on Mars. We're looking forward to that. The entry, through the surface of Mars and the eventual landing was quite an impressive one. It lasted about 7 minutes. And what's really, impressive about the landing is that you're carrying a rover that's about the size of a bakkie or an SUV, and landing it on this planet with atmosphere that's like a little bit thinner than here on Earth. But when you land through the atmosphere, you experience, heating from friction coming at this high speed, just as we see, sometimes with a falling star, as this falling star, this rock burns as it goes into Earth's atmosphere. This is what the rover had to be able to withstand. All this heat slow down, and eventually the landing in a location that's a bit treacherous on its own. It's a lake area, and so it's not a nice flat area, surface that a more conservative mission would go for. This is a lake area where we are expecting to search for signs of life, but can be treacherous. So the landing was really, really impressive indeed.
Now, Perseverance is expected to be on Mars for about 2 years, not only to collect samples, but also to conduct a few experiments. Can you tell us a bit more about the Mars Oxygen in Situ Resource Utilization Experiment, also known as MOXIE?
Yeah, that's an important experiment, its real mission is to be able to learn to start using the resources on Mars for exploration. And oxygen is one of these things that will be needed in future explorations, especially human exploration. We want to be able to use resources on Mars. And the atmosphere on Mars is predominantly carbon dioxide. So you want to be able to change that to oxygen if you're going to have humans there, and not carry all your oxygen from here on Earth. As we've learned now with coronavirus, we need this oxygen for other things, like us helping patients here on Earth. Anyway, we'll be able to do that on Mars, And actually, just saying that, I realized that the importance of an experiment like that here on Earth could be how one just turns some carbon dioxide in one's environment to oxygen for utilization. You mentioned the helicopter. This is really, really, really exciting, and I think at the moment, the helicopter is just doing a technology demonstration flight. So just testing whether you can do this. Mm-hmm. But the exciting thing going forward is you can imagine once this technology is demonstrated, it means future missions can have helicopters with them. So that would allow you extra flexibility on Mars. You'd be able to go to other places on Mars, on helicopter, be able to, just sort of do what you do with helicopters here on Earth. Go to areas that your rover cannot easily go to, ferry cargo that, at speeds your rover might not be able to, and indeed take imagery with this helicopter that your rover wouldn't be able to do, and that satellites orbiting Mars are too far to do. So this helicopter, if it works, opens a whole new window for future missions.
I can actually hear the excitement in your voice, Professor. Clearly, it makes it seem that this $2.7 billion mission is actually going to be worth it. Now, there's going to be a search for signs of any ancient microbes that might have actually flourished when water used to flow on Mars about 3 billion years ago. Now, what are the key findings that the probe is expected to make that will actually signal that it's safe for humans to be able to visit the planet and possibly even live there?
Yeah, that's a good one. So there are two parts to this, which is searching for ancient life that we think probably existed 3.3 billion years ago or so on Mars, and mostly microbial life. And the key thing really about this is that we've seen signs that there may have been water there, that there were, that life may have been able to be sustained. But now we want to actually see the real evidence and bring, this microbial evidence, which should be the first evidence of life ever on another planet. So that will be very, very key, and it will be done also by bringing samples from Mars back to Earth that will be analyzed in detail for this evidence. In terms of humans living on Mars, this is a slightly different issue in the sense that what you are really trying to understand is the environment of Mars, for example, the weather, and then planning for future missions where if humans go there, they would be able to, live in such weather conditions or just environment in general. You'd want them to be able to use the resources from the planet as much as possible so that you don't have to, ferry all the resources they will need when they are there. And then, of course, you want to be able to bring them back to Earth. I think in the earlier days, we were talking about, taking humans to Mars and never having, and doing a one-way journey. But I think things are getting a little bit more sophisticated now, that rockets that are being planned will actually be able to carry enough to get people there and possibly even get them back. And so the human exploration part, includes all that, being able to understand how humans will survive in the environment, use the resources, and also possibly come back to Earth.
Now, Professor, what happens at the end of this 2-year period that Perseverance rover is expected to be on Mars?
So the rover is essentially funded for 2 years, which means you can pay people to analyze these images, operate the rover, and all that. However, I understand the rover has enough power so that it would be able to do further work beyond the 2 years. So there could be more activity beyond the 2 years. But one of the things about the sample return is also that at the moment, the rover is only locating interesting sites where there could be evidence of ancient life, and then drilling and storing these samples. These samples will then be returned to Earth later. So there will be at least 2 follow-up missions to this particular one that will go to this landing site and go and pick up those samples. And so there's a lot more beyond the current 2 years.
And lastly, Professor, in just 1 minute, we've seen certain countries that actually dominate the space exploration at the moment. What do you think the chances are of South Africa getting involved in space exploration?
Oh, lots of chances. I mean, one of the things South Africa contributes to this work is being able to monitor basically the communications part of this. Have and use antennas here in South Africa to get some of those signals coming from these missions and the activity that's happening there. So that's definitely the direct way already to be involved. And then there's also like a real big possibility in terms of this analysis of the search for ancient life, because the signatures that are there in this ancient life, we have rocks similar to that here in South Africa. So already the science that's happening in South Africa can, really have synergy with the science that's happening now.
Well, thank you so much for joining us this afternoon, Professor Lerotodi Leo, an astrophysicist from the University of the Western Cape. We'll still